All right, IBAISL2. Today we're going to talk about area involving triangles. There's a lot of examples today, so I apologize, but I'm going to see if I can get through them all because it's 2.2. They threw two kind of big things at you. 1.5 really. Anyway, we'll talk about it. So the first thing we have to talk about is the area of any triangle ABC is given by this formula, 1/2 BC sine capital A. But just like the law of cosines, there's kind of three different versions of it. There's not really three versions. It's just kind of the ingredients being mixed around with the same structure. It's always 1/2 side sine of the angle between those two sides. So this is another angle sandwich situation where you have a side and then an angle between them. So if you know all three of those numbers, then you can find the area of that triangle. Now I realize you guys have been trained the area of a triangle is 1/2 base times height, or base times height divided by 2. But that's if you know the height of the triangle. This method is kind of cool because it has the height embedded in it using the sine formula. So it's kind of better because you just need to know two sides and an angle between them. Let's take it for a spin. This one's pretty simple. You got the angle sandwich. You got all the numbers, so you really, to find the area of triangle ABC, we're going to say the area equals, what is it again? 1/2 BC sine A. So it starts with 1/2, and then the angle, or the sides, multiplied, and then the sine of the angle between them. So when you crunch that out, you should get, and we're rounding to the nearest integer on that one. 11031 meters squared. Don't forget when you're doing area that it's meters or units squared. So since it was meters in both of these, you square it up. Also make sure, if you're not getting the same answer as me, that your calculator is in degree mode, since we're dealing with degrees in this problem. Next up, slightly different problem because they give us the area. It says the area of triangle ABC is 29.6 centimeters squared, but then they give us the angle 25 and on one of the sides. So we already know the area is 29.6, and that's equal to 1/2 BC, and then the other side is what we're looking for, AB. So we'll just throw AB in there as a little placeholder. And then that's times the sine of 25 degrees. What should we do? Let's just divide by everything. So I want to get AB by itself. So what I'm going to do is get rid of this and this by dividing both sides by that. I'm going to do it all in one move. So we'll divide both sides by 1/2 times 7 times the sine of 25 degrees. And this is equal to AB. Then you can punch all of this into your calculator, but just be careful. Use safety parentheses. So you do 29.6 and then a big parenthesis, or divided by big parentheses, and then you punch all that into the denominator. To 3 sig figs, this is 20.0 centimeters is equal to AB. Next up, find the area of parallelogram ABCD. They say that BC is 7.4 and AB is 12.3, and we know angle B. Now, you might look at this at first and be like, well, I don't know how to find the area of a parallelogram. I only know how to find the area of a triangle. That's what you just taught me. But if we look at this guy, you can split it into two identical triangles. They're identical because this is a parallelogram. So this will be 7.4 and this will be 12.3. And then the opposite interior angles of a parallelogram are also themselves. So we just need to find the area of one of these triangles and double it. So the area of the triangle is 1/2 12.3 times 7.4 times the sine of 39 degrees. But if we want the area of the parallelogram, we just need to double that. That's my drawing of a parallelogram. 2 times 1/2 times 12.3 times 7.4 times sine of 39. Now, we could crunch this all out on a calculator, but I want you guys to realize that if we're doubling the area of that triangle, the 2 and the 1/2 are just going to cancel each other out. So really, we could save a little bit of computation and just do 12.3 times 7.4 times sine of 39. And when we do that, you will get 57.3 centimeters squared. All right, that's that one. Oh, you guys, the area of any parallelogram is just going to be AB sine C. That's because if you chop it into two triangles, each of those will be 1/2 AB sine C, but if you have 2 halves, that makes a whole. So if you need to find the area of a parallelogram, just use AB sine C. Next up, we got an isosceles triangle. Remember, isosceles means that two sides are exactly the same. In fact, they tell us that PQ and RQ are the same. So I'm going to go ahead and mark that PQ and RQ are the same. The angle P is 61, and we need to find, and PR is 12. We need to find the area of PRQ. Well, let's see. How do we attack this? Wait, PR... Okay, PQ and RQ are the same. This is kind of a two-stepper. It seems like it'll kind of stump you at first because trying to figure out these two sides that are the same is a little. You can't just do it in, well, you can do it in one step, but there's a couple steps is what I'm saying. First up, if this is an isosceles triangle, there's a relationship between the sides of triangles where if the sides are the same, that means the interior angles are the same. So that means this is also 61 degrees. Now this angle up top, if we subtract both of those 61 degrees off of 180, we can figure out that top angle is 58 degrees. Now, we still don't have an angle sandwich to be able to find the area, but don't forget all the rules that we've already done. We have law of cosines in our pocket, and now that we know this angle and this side, we can use that to find either of these sides. So let's find side QR. So sine of 58 over 12 is equal to sine of 61 over QR. So then cross multiply and get QR. Sine 58 is equal to 12 sine 61. So QR is equal to 12 sine 61 over sine 58. Crunch that real quick. So this equals 12.38. So what that means in our diagram is that this side is 12.38 and this side is 12.38. So now you can find area of the triangle by doing 1/2. Well, there's, God, take your pick. There's so many different ways to do it. 12, I'm going to do 12 times 12.38. And then the angle sandwich between them is 61. That is about 64.9 centimeters squared. Next up, find the area of triangle ABC. Well, to find the area of triangle, we need one of the angles. So once again, don't forget about every tool you already have to find angles. I'm going to find angle C using the law of cosines. All right. Check my other video about law of cosines about how to solve the algebra of that. But when you do solve this, you will get that C is about 100.98 degrees. Now that we have that angle, which is 100.98, we can just do that area is equal to 1/2 7 times 12 times the sine of 100.98. When you crunch that, you should get about 41.2 meters squared. There's the area of the triangle. The last thing we're going to do is the area of a sector. Now, a sector is just a fancy name for a pizza slice. So, in this diagram, if you take a slice of pizza that touches the center of the circle, oh yeah, that's an important distinction, that this is the center. This is called a sector. The way you find the area of a sector is with its central angle. Oh yeah, the angle that it touches at the middle is called a central angle. It's the central angle divided by 360, which makes sense because it's like whatever your pizza slice is out of the total circle being 360, and then you multiply it by the area of a circle. The cleaned up version of this formula is theta pi r squared over 360. Very basic test drive. Let's find the area of this sector. Oh, I forgot to put the directions, but yeah, let's find the area of here, I'll put it. Find area of sector BAC. So we're going to find the area of this pizza slice right here. At first you're like, wait, they didn't put the other side over there. But remember, it's a circle, so all the radiuses are the same, radii. So we have 5 and 5. So the area is going to be, what, theta, 120 degrees, times the radius, which is 5. Or no, it's pi comes first, sorry. Pi r squared. So pi 5 squared all over 360. So that is 26.2 meters squared. That's it. Next one, working backwards a little bit. They give us the area and we need to find the central angle. So the area is 30 pi. And then it's theta pi r squared, so we don't know the theta. Pi, we do know the radius, 13 squared, all over 360. Excuse me. First thing I'm going to do is multiply both sides by 360. So when you multiply the 30 by 360, you get 10800 pi is equal to x pi, and then 13 squared is 169. Now let's divide both sides by pi and get 10800 is equal to 169x, and then you just have to divide that number by 169, and we get 63.9 degrees. Don't forget that x was an angle we were trying to find. Last one, we're going to find the area of that little shaded region. They tell us sector AOB has a radius of 4, so I'll go ahead and pop another 4 over here just to remind myself, because that's a central angle, which means this touches the center. Those are both radiuses. The angle between them is 75 degrees. Determine the area of the shaded region. Here's the game plan. I can find the area of the sector, and then I can find the area of this triangle. And if I subtract out the area of the triangle from the sector, I'll get that little crust that's left over, keeping with my pizza analogy. So the shaded area is going to be sector minus the triangle. The sector is 75 times pi times 4 squared, all over 360. And then the area of the triangle is 1/2 4 times 4 times sine of 75 degrees. So, the area of the sector, if you crunch that out, is 10.47 centimeters squared. And then the area of the triangle is 7.73 centimeters squared. And then if you subtract both of those, you should get about 2.74 centimeters squared, of course. All right, you guys, that is it. Happy studying. Hit me up if you have questions.